lesson the other day, we had our triangles and we measured all our lengths and we squared them. Now, we've shared our results. Now, obviously, this table as it is are not correct because 5.9 squared is not 36, but that's because we shared our results. Now, as I've said, we have to remember that this is a practical situation, so it's not perfect. I've said here, what do you notice about the values for each triangle? So, what I would like to try and do is to try and focus looking at the values for triangle 1. Okay, so is there any connection between anything here? Then have a look at the values for triangle 2. Is there any connection between those ones? And so on and so forth. So I want you to see if you can see any connection between the horizontal numbers, not necessarily the vertical ones. Okay? I'm going to give you a couple of minutes to see if you can see. Sure, okay, you two can work together. You two can work. What do you mean you can't see?
No, I mean like I can't see any changes currently, like, or similarities.
Okay, so you two can work together, you two can work together, you two can work together, and you two can work together. Okay? So Kaya, you're with James. Alright, so have a look at your numbers and see if you can see it.
Not all of them are right.
Alright, okay.
Most of the numbers are even.
Alright, so we didn't seem to come up with it. Alright, can you tell me anything special about this, well, this column or this one compared to the others? Is there anything special about that one compared to the others?
No.
None.
No.
The numbers are always right.
No, that is not over.
Yeah,
we all have a. Okay, it goes 230, then it goes.
Not necessarily the actual numbers. Is there anything special about this number here
Oh yeah, the all
compared to this one and this one, or this number compared to these two? Is there anything special about those numbers?
Oh, I see they all begin to 5.
No, they don't. Really don't.
Yes, she pointed to the A and the
Yes.
E. And the C.
Okay, what about the size of them?
I would say that they will like they would go 36.
Small, they're all
No,
small.
but then the next one's 30.
This one here. Looking at this row here, is there anything special about this one compared to these two?
Yeah, it's the biggest.
Who's the biggest? Is it always the biggest?
No. Oh wait, it goes another one. It goes.
Is it? Ladies. Okay. This one here is 5.9, yes?
Yeah.
Is that bigger than 5.6 and 2.2?
Yeah.
Okay. This one here was 5.4. Is that bigger than 3.3?
Yeah.
Is it bigger than 4.4?
Yeah.
Great. So so far we've had the biggest one. This one's 10.1. What was this one? Is that the biggest?
Yeah.
This one?
Yeah.
This one?
Yeah.
Alright, so what can we say about length A? Side length A. Side length A is the biggest for each triangle. Right, you don't have to, just start by length. Okay? So the length A, or side length A, is the biggest for each triangle. Is B always the next biggest? And C the smallest? No, okay, so that was a mix up, but it seems that A is always the biggest one. Okay, so that's...
Wait, oh, does that mean that it's the hypotenuse?
Oh, fancy pants. It is the hypotenuse. Yes, we're going to talk a little bit more about how we label things in a minute. But that is right, Sarah, that's the hypotenuse. So, A is the biggest one. The other two we're not sure about, but I did say not necessarily to focus on the length we measured. What's the matter? Triangle.
It looks like big.
Alright, ladies, shall we not discuss what you think it looks like? It says the word triangle. I said the word triangle. It's written triangle. If I started to go through all your writing, I'm sure I could find quite like they're supposed to do. Okay? So, side length A is the biggest for each triangle. I did ask you to look at the squared columns though. Is there anything that we can see about the squared columns? Nothing.
No. No.
Oh, did they go from
Yeah.
Okay,
I found something.
what did you find?
Well, it's just like how you said for the A, because the A numbers are bigger, the square numbers are bigger than the other square.
Yeah, so these are always beginning those. Yeah, absolutely. Okay. What about, what's this number here?
31.3.
And what's this number here?
5.29.
What would happen if I added these two?
You get 36. Oh wait, no, you would. Sorry, I was just trying to guess.
Well, roughly, what do I get?
Oh, you
Roughly.
Do I roughly get this?
Yeah.
What about if I add these two?
You'd roughly get 30.
Oh my god.
You get like
What about
28.
these two?
You roughly get 104.
What about these ones?
You'd roughly get 100.
What about
You'd
this
roughly
one?
get
You roughly get 265.
That's excellent.
Yeah.
I'm not impressed.
Yes.
So is there a connection between them? Well,
Yeah.
No. You roughly get the numbers.
the column b squared plus c squared is approximately
Oh yeah, I didn't
equal to a squared. Okay, so the columns b squared plus c squared, I should say are approximately, sorry, not is, are approximately equal to a squared. You written that down?
What you say? Ready?
Right, so those final two columns, when they add together, actually are approximately equal to the a squared column. Now, hopefully you found that in your individual diagrams as well. Now, why have we been doing this? Well, this rule that someone found is known as Pythagoras' theorem. Have you heard of Pythagoras? Is it a god?
It sounds like you're going to
He was a mathematician. Now, if you wish to, you're very welcome to go off and find information about Mr. Pythagoras.
There's a picture around the hallway of like this cartoon, but
Okay, so if Pythagoras was a very, very famous mathematician, and he found that this rule applies to any triangle that has a right angle in it. So, what's a right? Well, when I say right angle, what do I mean by right angle? Would Yes. So if we have a triangle that has a 90-degree angle in it, then this rule follows that these two sides, when we square and add them, it's equal to this side squared. I think that's pretty cool. So I
you have to label it correctly or it won't work.
Absolutely correct, Abby. You do have to label it. Now, as Sarah said, Sarah threw in the little fancy word earlier. What word was it, Sarah?
Hypotenuse.
Hypotenuse. This is what we call the longest side. It's called the hypotenuse. The hypotenuse. And hang on a second. The hypotenuse is always the longest side of a right angle triangle. Okay, so the hypotenuse is always the longest side. And it's actually always situated in the same place. It's always opposite the right angle. So in a diagram, this length here, that's opposite the right angle, is always going to be the longest. Okay. The other two we've labelled B and C. Now, as we saw from this from our chart, it actually didn't matter whether B was the medium size or the smallest size, or if C was the medium or the smallest. These are known as the two shorter sides. So, Pythagoras' theorem, as it says here, states that the sum, when I say sum, what do I mean when I'm doing something? I'm summing it. As the sum of the squares of the two shorter sides is equal to the square of the hypotenuse. So the sum of the squares of the two shorter sides is equal to the square of the hypotenuse. Have you written that down, Abby? Really pen to pen.
I'm gonna cut you off because I don't want to be rude.
Alright, so lots of discussion there. So if we knew that x squared was 169, then we have to do the opposite thing. We have to undo this square, don't we, to find x? And we remembered eventually that the opposite of squaring was?
Square rooting.
Square rooting. So we're going to find the square root of 169. So in other words, what we're finding is which number multiplied by itself gives us 169. It's 13. So in this case here, our answer is 13. Now, it's really, really important because sometimes when you're in a test, people get confused and they forget to do stuff. And I've seen before that people said, right, okay, x here, that's 169. Does that look sensible?
No.
Looks a bit dark, doesn't it? Yes? This can't be 12, and this 5, and this 169. That's just ridiculous. Okay, that's not going to happen. So, what I want you to make sure you're doing in your tests is to try and think, well, hang on a minute, that doesn't look right. What am I supposed to do? What am I supposed to do? I remember I square root it. Okay? So that will hopefully mean that you will avoid making any careless mistakes. Sarah?
Can I go to the bathroom?
Okay?
Back to the next question.
Well, okay, now this next one is a bit trickier. Why would this one be trickier?
Oh, never mind. Because
Oh, wow.
just because this one is like supposed to think it's a part of the thing, and if that was supposed to be the longest, then the longest is already there to see that.
Exactly. Now, what Maya said was that in this question here, we've been given the longest side. Okay? So they've given us the thing that we're used to adding and squaring to give.
Oh, so you take away.
So we're going to end up doing what, Abby?
We're going to take 8 away from 2.
Well, not 8 squared. We're going to subtract in this one though. What we can do is start off by using our rule. So what do we want to call this one? Still x? Or y? Or what do you want to call it?
A.
Why?
Oh, I'm going to call it x.
K.
Alright, so you can call it what you like. So I'm calling mine x. So if I were to write my normal rule, I would say 10 squared is equal to x squared plus 8 squared. Do you all agree with that?
Yeah.
So 10 squared is my hypotenuse. 10 is my hypotenuse. So 10 squared would equal 8 squared plus 8 squared. Because these are my two short sides. Yes? Remember the order doesn't matter. It could be 8 squared plus x squared. But they all have to be squared. They all have to be squared. and they have to equal the hypotenuse squared. Right, now this is where your rearranging is going to come into play. It may be that doing this one here might make it a bit harder. What you might want to do is say, right, I'm going to always start my sentence with my letter that I'm missing. So I might always start with x squared. No matter whether it's a long or short side, I'm always going to start with x squared. If I did that, then that means that I need to rearrange this. So x squared on its own, what do I have to do to make sure that x squared is on its own here? What do I have to get rid of? Which the 8 squared, yes? So when we're getting rid of it, it was adding on to it here, so I have to do the opposite procedure. So I have to
minus x from, you minus 8 from x, and you also minus it
from 10 squared, yes.
Wait, this is
Yeah. Okay? So we're always going to be subtracting it, and you're always going to be subtracting it from the hypotenuse squared. So when you are finding a short side, this one is always going to be the hypotenuse, and this is always going to be the short side. And it will always be subtract when it's a shorter side. Okay? So now we're going to finish off in a similar way that we did before. So we're going to chuck in our calculators, not 10 squared plus 8 squared, but 10 squared subtract 8 squared. So it gives us 10 squared, 10 squared plus subtract 8 squared.
I wanted to say it.
Okay, so 10 squared subtract 36. 10 squared subtract 8 squared is equal to 36. What do we have to do to get our final answer? Square root it. Square root it. So we're going to square root 36. Who knows without using a calculator what number multiplied by itself? Oh. And in this question, what was our unit?
Millimeters.
So we should keep our units the same. Okay, this one here. Are we finding a short side or a long side? Are we finding a short side or a long side?
The medium side.
How would you get 36?
You square.
Oh, it's a calculator. 10 squared subtract 8 squared.
Oh.
Okay. So the one that's missing, a label, is it a long? Is it the long side? Is it short? Is it the long side or is it one of the short sides? Short. Okay. So because it's one of the short sides, it means that is it going to be add or subtract? Subtract. Bless you. So I guess we're going to call it x. Bless you. I'm going to start with x squared equals because I like to do that. I don't really like rearranging. I'd like to have my answer straight away. So x squared. We're trying to find x squared. So what am I going to write here on for this one, Georgie?
X squared equals 10 squared times plus 6.
Careful.
Minus 6.
No, it's going to be subtract because we're finding a short side. Why did you start with the 10? Good. Yes, exactly why. Alright, so always start with the biggest number here. So 10 squared subtract 6 squared. So x squared is equal to 64. Is that our final answer?
No, we have to square root it.
So x means square root of 64, which is 8. And in this case, we're talking meters.
Right.
Alright, number 4.
Wait. I forgot why you subtracted. Why do you subtract it?
Okay, because we are finding one of the shorter sides. Okay? If we were finding the long side, that's the only time we add. If we're finding one of the shorter sides, we always subtract.
This one kind of confused me when I got to 18.7.
Yes, it would be confusing, and the reason that it is because I'll tell you next time.